Good evening, everyone, and I'm so happy to welcome everyone live to Jenny Jump and excited that everyone is back. Our speaker tonight is co-founder of the United Astronomy Clubs of New Jersey. He has been an amateur astronomer since age 10, holds degrees from Stevens Institute of Technology in Physics and Computer Science, and is a member of the International Association of Astronomical Artists. In April 2016, the UACNJ dedicated the Lonny Buinis Observatory. You've probably heard the moon landing was faked, but do you know there are other well-established astronomy myths? Let's debunk a few, especially the old advice to preserve your night vision with a red light. Space animator and artist and perpetual skeptic, may I introduce Lonny Buinis, my husband, who will now help us to see how to nix the 6 myths.
Thank you, Jan Buinis, and our viewing audience will have to pardon us for our amateur production. This is not a professional studio, but a home office. And I see by my new watch, I just got a new watch, that it's about time for us to begin. This Solex actually works. It's available online for only $3,000. I think I paid 30 cents. And so by my clock, it says it's time for red light and other astronomy myths. How's that for special effects? The goal for tonight is to nix 6 myths. Let's start with number 1, well-worn adage, edict, old saw. Feel free to look up any of these terms, any special terms we're using tonight. I expect members of the audience to consult their mobile devices, their dictionaries. What's that? Check out dictionary.com. The moon landings never happened. It was all, to use the scientific term, faked. Number 2, at one time, everybody thought that the planet Mars had canals on it, artificial canals. Everybody thought that about 100 years ago. Number 3, the so-called planet Vulcan, not the one that Spock was born on from Star Trek. This was a mythical planet Vulcan within the orbit of Mercury. They thought, well, it was a mistake. Somebody saw a sunspot. Number 4, seeing. What do we mean by seeing? Look it up. Seeing, the effects of the atmosphere on viewing objects that are far away. It affects large telescopes more so than small telescopes. Number 5, with a big enough telescope, you can see through clouds, and you could also see the disks of stars. And number 6, my personal favorite, red light is best to preserve your night vision. We're about to see why all of these things are myths. None of them are completely true, and most of them are completely false. So we'll come away with an understanding for you to pass the test at the end of tonight's presentation. The moon landings were faked. Check out badastronomy.com. This is a picture of the founder, Phil Plait, who's written a book called, you guessed it, Bad Astronomy, who has some very good ways of dispelling some of these myths. If you really look at how such a thing could be faked, it's very easy now to do it. Well, almost anybody could do it with a laptop computer and an animation program and 3D modeling. And this is the sort of thing that I do, hopefully professionally eventually, 3D animating for astronomy. But back 50 years ago, when the moon landings happened, over 50 years ago, right? July 1969. It wasn't that easy to do things digitally. In fact, it was downright impossible. Now, one of the favorite ways of dispelling the idea that the moon landings were real was that the shadows are not parallel. You would expect that a light source that's infinitely far away, the sun, would cast parallel shadows, right? The further away something is, the more straight the lines coming in from that object. It's a matter of basic perspective. And so it must have been a studio, right? And the Van Allen radiation belt was another excuse that humans would be irradiated and would die, but that's not true. We're looking at a fellow who was famous for conspiracy theories, a talk show host, television, who actually ended up accosting one of the Apollo astronauts. So take a look at these shadows here. You see the distant shadow from the Lunar Excursion Module, LEM? Some years after the lunar landing, about 10 years or so. No, it's actually more like 20. I used that term, and a computer animator who was building a model of the Lunar Excursion Module had no idea what I meant by LEM. LEM, NASA acronym for Lunar Excursion Module. All right, the shadow looks pretty straight out in the distance, and right here in the foreground, the shadows aren't parallel. From a light source infinitely far away, you would expect the shadows to be going straight out to the right, wouldn't you? Well, Phil Plait did a little experiment with a friend and showed that the horse trailer shadow is straight, and in the foreground, a person casts a shadow that isn't obviously as straight. Why is this? Because of basic terrain. It depends on how big an angle you're looking at over how big an angle of the landscape. And it turns out that conspiracy theorists who believe that this is a prime reason why the landings were fake aren't paying attention to basic topology, the way that a changing landscape casts shadows. They aren't parallel. And the closer you get to a light source, if you were to look further to the left of the picture and the right, and there were more of it, the closer you get to the sun, the straighter the shadows will be pointing straight at you. You can demonstrate this for yourself by looking toward the sun, watch the shadows near the sun, then turn your head 180 degrees to the opposite direction, and you'll see the shadows are pointing away from you. The whole idea that the moon landings were fake were a tremendous insult to Edwin Eugene Aldrin Jr., better known as Buzz Aldrin, who came from, you guessed it, the state that many of you are viewing from right now, New Jersey. This New Jersey astronaut, guy who grew up to become an astronaut, was accosted by the fellow in the previous picture who told him that the moon landings never happened and you are a fake, a coward, and a liar. And for that, Buzz Aldrin punched this fellow in the face. Now, I'm not advocating violence. Young members of the audience, it's not a good solution. But when you insult an American hero, you have to expect that something like this will happen. I'm not going to play the YouTube video. You can find that for yourselves. Do a search on Buzz Aldrin punches guy. I like to go with Phil Plait's adage, the universe is cool enough without having to make up crap about it. He presented this at a conference hosted by James Randi, who is a famous magician, famous for debunking myths, especially myths about spoon-bending psychics and basically frauds, people who fake being psychic. I'm not saying that there aren't real psychics out there. I'm just saying that a lot of people tend to fake things, including people who make up stuff about the universe that's faked, especially saying that the moon landings were faked. That's a terrible insult to the ingenuity of the American engineers, scientists, draftspeople, utilities people. Thousands, hundreds of thousands of people were involved. Do you really think the U.S. government is capable of a cover-up of that magnitude, able to silence that many people? Does the government do anything really well? A few things, yeah. But that, think about it. The canals of Mars were easy to explain, right? Everybody saw them back 100 years ago, and so it became a myth. Or was it real? Well, actually, it's not easy to explain why people thought they saw canals on Mars. Back 100 years ago, optical telescopes were the way to observe the sky. Radio astronomy, brand new, right? We didn't have space probes, no robots. It's really complex to explain this. There are 6 reasons the orbits and axes of Earth and Mars line up in peculiar ways. The Earth's atmosphere interferes with seeing. There's that word again, seeing. Ask some of the amateur astronomers tonight, when you go observing through their telescope, why the images might look blurry and then clear up if you keep staring at an object, especially a planet like Jupiter or Saturn, both of which are visible tonight, and possibly also the comet Neowise. Human vision is tricky. Humans tend to see things that, well, frankly, aren't there. And there are psychological reasons. There are physical reasons, which we're going to discuss later. 100 years ago, the refracting telescope, refractor, dominated the field. The coatings on mirrors were not as sophisticated as they are now. They tarnished readily. And so it was difficult to get good imagery. And figuring mirrors difficult, as is figuring a lens. But the lens dominated the beginning of the 20th century. The refracting telescope comes with its own limitations. Refract, by the way, means bend. And think about what a magnifying glass does. It bends light, just like the lens in an astronomical telescope. The surface of Mars, peculiar and flat, low in relief. The atmosphere of Mars interferes with vision as well, just as the atmosphere of Earth. But the most important reason that it's not easy to explain why not everyone saw canals of Mars was the power of the pen. The power of the pen. Just as now, we have famous personalities like Richard Hoagland and Albert Gore, former vice president, who tell us things that aren't necessarily so. Famous people who can sway us with their persuasive powers. Back 100 years ago, Percival Lowell, Arizona astronomer, a rich man who made his own observatory. He was a businessman who saved a lot of money, built his own observatory, dedicated it to viewing the planets, especially Mars. And he wrote books. He wrote several books on Mars that convinced people that Mars was inhabited by intelligent life. And this set off generations of astronomers and science fiction fans and people like myself. For when I was a child, the ideas of Lowell had been discredited, but the romance that he set off, inspiring authors like H.G. Wells, The War of the Worlds, Ray Bradbury, The Martian Chronicles, Edgar Rice Burroughs, The Martian series, the Barsoom series. These inspired generations of young people, just such as myself. Now, this is not to imply that I am young now. Far the contrary, I've been around since approximately the Triassic period. Look it up, you people with your cell phones and tablets, and Google, right? Check out Triassic. How long ago was that? There will be a test later. So there are at least 6 reasons that people thought there were canals on Mars. All this is described in great detail in my interactive book, Space History Mysteries Solved. And you can see a picture of Mars on the cover, on the upper left. But that's my sole and one and only advertisement for tonight. I promise I won't do it again. Check it out. It's interactive. It uses 3D objects that you manipulate with your fingers. You can move images of Mars, 3D models of Mars with your hands, and compare a Mars from 100 years ago with Mars of today, and see why the canals are an illusion. Speaking of Mars, I've just finished a 3D model of Mars that you can manipulate with your hands. This is going to become, this is my new project. It's going to be, I hope, published as a multimedia interactive activity for you to purchase at a reasonable price. It will contain 20 narrations done by my wife Jan that explain not only individual features on Mars, but details that might not be described. I can pull this thing around. Oh, I can even use my fingers to move the model, to look at a giant volcano, to zoom in on the model, like so, fourfold. So I can look at Olympus Mons, a gigantic volcano on Mars. Let's make things a little bit brighter. All right, and so you'll be able to play with models like this. And if you'd like to play with some free ones, go to my website, astronomyinmotion.com, and look for VR, virtual reality. That's what that is. Percival Lowell also drew canals on Venus, pictures of Venus that he made, and Mercury. And he was ridiculed for this 100 years ago by the general public and especially astronomers. And so he experienced what was then called a breakdown of the nerves. A breakdown of the nerves. Can you imagine? Can anybody tell me, raise your hand, if you know the modern term for a breakdown of the nerves? Go ahead. I can't see you, but you can raise your hand anyway. And maybe one of the astronomers in the audience can tell you. Yep, you're right. All of you in the front row, I'm imagining that there are people in the front row, which is difficult to do, especially when you're outdoors and there's no rows. Yes, a nervous breakdown. Percival Lowell recovered from his nervous breakdown, went back to the telescope, looked at Mars again, and saw the canals coming back year after year after year of observation. He wrote in his book, Mars and Its Canals, so convincingly, a book that I read twice, by the way, so convincingly you would believe that they were there. He was so convincing, he was so powerful in his persuasive powers. So what was he seeing? Well, Percival Lowell stopped down his telescope from 12 inches to several, turning it into an ophthalmoscope. He was examining the enlarged blood vessels of his eye because we now know that he suffered from hypertension, high blood pressure, which tends to enlarge your blood vessels, especially in your eye. And so he was drawing his blood vessels superimposed over the canals, the naturally streaky features of Mars, where there are no canals. Isn't that something? He did it for Venus and Mercury as well. And here's a shot of the fovea of a human eye, the point where things focus, where the blood vessels enter the eye. Notice how similar the pattern he drew on the planet Venus. Another myth, Vulcan, the innermost planet that we now know does not exist, would have orbited close to the sun within the orbit of the first planet, Mercury. Mercury was a sunspot. Now this explanation goes even to this very day. The first observation that sparked the whole thing, that inspired people to believe that there was an innermost planet, was a black spot crossing the sun. It was seen by an astronomer named Edmond Lescarbault, who lived in France, who observed something crossing the sun in 1859. Was it dirt? Was it a sunspot? I believe it was an insult to attribute these explanations to an experienced amateur astronomer, Edmond Lescarbault, who built his own solar observatory attached to his office, for he was a doctor, a country doctor, in an area in France that has now been engulfed by the suburbs of Paris, about 40 kilometers away from Paris. Quick, what's 40 times 0.6? I see several mathematicians in the audience scrambling to bring up the calculator app on their phones. Very good. Good, I see that technology has not made amoebas of all of us. If you'd like to see where we're headed, watch the movie Wall-E, a Disney Pixar production, which predicts in the future that machines will do everything for us and we will be lazy. kind of like we are now. In his wonderful small book, The Hunt for Vulcan, just published a few years ago, Thomas Levinson describes how dedicated Lescarbault was, painstakingly constructing his observatory, observing year after year, trying to see if he could find the innermost planet Vulcan, because an astronomer, Urbain Le Verrier, predicted the existence of the planet Neptune from perturbations on the orbit of Uranus. Uranus had been discovered visually, but predicting where it was in its orbit was always off a little bit. Why? Because another planet was pulling on it, influencing it by the force of gravity. And so Le Verrier successfully predicted the position of the new planet Neptune. With this success going to his head, he tried to predict weird occurrences in predictions for of where Mercury would be in the sky. And so tried to predict where the new planet Vulcan might be. This is Lescarbault's observatory with the dome up top. Orgères, France. And so one fine April day in 1859, that Lescarbault noticed a tiny dot moving slowly across the sun, taking over an hour to do it. So I've sped this up in this animation. Part of my book, Space History Mystery Solved. Oh no, he's advertising the book again. Oh, geez, when will he shut up about this already? Lescarbault was interrupted at one point. He was impatient. He had to go tend to a patient of his. He was a doctor. And so rushed back after seeing the patient, was glad to see the dot crossing the sun was still there. Now Lescarbault had years of experience timing patients' pulses by counting seconds. So he was able to accurately time how long it took for the little black spot to cross the sun. Having seen an earlier, 14 years earlier, transit of the planet Venus across the sun, something that happens only once every century and a quarter or so. I was lucky enough to see one back in the 90s. I won't live to see the next. Lescarbault knew the size of the spot was a quarter the size of the planet Venus as he had seen it 14 years earlier. So he had a good estimate of its angular size. He knew the time it took to cross the sun. We also now know the size of his telescope, a 9-inch refracting telescope. And from all these clues, is it possible to tell what that little black spot was? Is it? Can we be scientific detectives and tell? Well, the answer is yes. There is enough evidence that I put forth in my book, The Mystery. Oh no. Yep, he's mentioning the book again. Which has an animation of what this object might have been. There are 8 possible explanations, including aliens. Yep, don't laugh. All right. I see somebody in the audience laughing. Now cut it out. Yeah, aliens. It's not a good explanation. I didn't say it was a good one. It was number 7. The idea is that a close Earth-crossing asteroid nearly collided with the Earth and passed on its way either into the sun or in a hairpin turn around it. And this is an animation from the book. And so we may have solved the mystery of what the initial Vulcan observation was. It inspired 56 years of a fruitless hunt for the inner planet. Le Verrier recalculated the position of the new planet time and again based on each new observation, and every time nothing showed up. Nothing. We now know from space probes that there could be no objects larger than a few kilometers across, but there is a stable area where things could orbit closer to Mercury, except they'd have to be tiny. They could not be planets. All right, another myth. Seeing in telescopes, large and small. Seeing, it affects how clearly we can see details on planets like Mars. A refracting telescope also introduces color aberration, spherical aberration, which can be corrected, and all the different colors that are in a beam of light can't be focused to the same point. They cannot. Light consists of wavelengths, different wavelengths of light. Different energies have different wavelengths. Longer wavelengths are associated with lower energy light, like microwaves and radio, and red, and infrared. Infrared light, the kind that comes off your campfires. We can feel it, we can't see it. Ultraviolet can be seen by honeybees. Flowers have ultraviolet patterns like landing strips on aircraft, on airports. It guides them in. Humans can't see them, bees can. Telescopes cannot focus all the rays of light to one point perfectly, and so early astronomical instruments put false colors and made the seas of Mars look, instead of the actual gray that they are, look greenish or bluish. That's seeing. Seeing does affect all telescopes equally, large and small. Another myth, if you had a big enough telescope, you could see through the clouds at night, right? It doesn't matter if you had a cloudy night. Some of the telescopes at Jenny Jump are huge, right? There's a 16-inch telescope in the Greenwood Observatory with the roll-off roof, open to everyone. Other observatories are run by member organizations, astronomy clubs. There are many in New Jersey and Pennsylvania that all belong to the umbrella organization UACNJ, United Astronomy Clubs of New Jersey, UACNJ for short, run entirely by volunteers, helping you right now in your observation outdoors, pretty soon when it gets dark. Well, it turns out that how well can you see when you're driving through fog? Can you see the landscape on the bottom of this picture? No? Having trouble? Well, seeing through clouds is just like trying to see through ground fog. Ground fog is a cloud. The water droplets refract and hide the light of the distant stars. No matter how big an optical telescope, you cannot see through clouds. You can see through clouds with longer wavelength light, red light, radio waves. I'm sorry, not red light, but longer than red, longer than infrared, longer than microwave, radio waves can penetrate clouds. They can also penetrate the heart of our galaxy and see more clearly to what's happening there. They can see through some of the dust that gets in the way. How about seeing the disk of stars? Can you actually see star spots in an optical telescope? This is a picture of Albireo, the head of Cygnus the Swan. Ask one of the astronomers tonight to show you Albireo if it's clear. This is known as a double star, and it's one of my favorites for its beautiful color contrast, gold and greenish blue. Check out Albireo. Go to Wikipedia. Well, now we actually do have images of the disks of stars. This is the star in the heart of the Scorpion, the rival of the planet Mars, because every so often the planet Mars passes along the signs of the zodiac, right past Scorpius, the... Yes, you in the front row? I see you raising your hand. Scorpio, I see. Yeah, Scorpio is the zodiac name, that's right. I'm pretending to see people in the audience. I can't see a darn thing, but I'm pretending. I've got a good imagination. Yeah, Scorpio is the zodiac name. Scorpius is the Latin name used by astronomers. The heart of the Scorpion, anti-Aries, the rival anti of Aries, the war god Mars. We can actually see star spots. Betelgeuse is embedded in a giant disk of dust and gas, possibly blown off by its own tremendous radiation, possibly because it's embedded in a large disk already that never formed planets. And recently, those of you who've been watching the news or listening to some of our amateur astronomers observing the star, or going out, if you just went out during the winter and looked at Orion the Hunter, you would have noticed that Betelgeuse was noticeably dimmer than it's been years past. Something passed in front of it. These are actual images made with interferometric techniques simulating a gigantic diameter telescope that can get a high resolution, a high sharpness that you cannot get in ordinary telescopes like the ones you see at Jenny Jump, even though one of them has a mirror about 25 inches across. Also, stars always look like this if you blow up the image of a star big enough. You get not an image of the actual disk, but an airy disk. Look up AIRY, disk. It's created by the wave nature of light. Light and subatomic particles are very peculiar. They behave like three-dimensional waves. They can be described mathematically as a wave, but it's hard for humans to picture that. I always picture photons of light, the single units of light, the lowest possible quantity of light that you can have, a quantum of light, a photon, as being like a cloud. It exists mostly here, but also a little bit further away it fades away a bit, and a little bit over there it's not quite. And did you know also that photons exist in the here and now mostly, but they also exist a little bit in the past and a little bit in the future? Isn't that spooky? They interfere with themselves, both in space and in time, because Einstein showed us that space and time are really a single unit called space-time that can be described mathematically. In telescopes of any size, with a high enough magnification, you see only an airy disk, and you cannot resolve stars that are too close together because their disks merge. This defines the resolution of a telescope. How well can you split a close double star? And there's a general rule of thumb for that. Go on Wikipedia and look up Dawes limit. D-A-W-E-S, Dawes, was the first to put in writing the limit of resolution of optical telescopes. Dawes limit. In telescopes large or small, you will never see the disks of stars unless you simulate a much larger telescope, miles across. My favorite myth is that about red light, using red light to preserve your night vision. Amateur astronomers, not just now, not just years ago, but for decades, have fallen in love with this concept. Why? And we're going to see, I really hate to do this, oh, it pains me, but it's false. You can buy red lights, you can buy red headlights, you can buy red flashlights, you can buy filters, you can put them on your flashlights. You can make your own if you can't afford to buy something. Does anybody have red cellophane from anything anymore? Does anybody even know what cellophane is? Yeah. It used to be used to make movies. It's highly flammable. They used to use silver nitrate on cellophane to make film. I had a friend who was running an old silver nitrate film. They don't even use this anymore. They use a much higher technology, and now everything's digital anyway. So if there's any film left, it's not silver nitrate. That was used a long time ago. Well, he was running it through a hot projector, and it caught fire and nearly burned his apartment down. Very exciting. Well, humans have a disadvantage. We don't have a Tapetum Lucidum. I think I left mine in the refrigerator, or maybe on one of the shelves. I'll have to ask my wife to help me find it. No, actually, a Tapetum Lucidum is a special reflecting layer in the back of the eye, behind the rear of the eye, which has sensitive cells. There's a reflecting layer in many animals, and that's why you see their eyes at night. We don't have that. We humans have poor night vision, and this contributes to the problem of using dim light to read things like star charts, like the Uranometria 2000, famous star chart used by many amateur astronomers, contains thousands of objects, tens of thousands of non-stellar objects, stars down to magnitude 9. We humans are limited to magnitude 5 or 6 in New Jersey. 6, you're going to be lucky to see magnitude 6. The magnitude scale is a logarithmic scale. It multiplies. Each step is 2.54 or so, right? So going from magnitude 0 to magnitude 5 is 100 times dimmer, 100 times logarithmic. You multiply each step, you don't add. Right, so most star charts that you might want to look at would show only magnitude 5 or 6 stars. So the idea is that the human eye has different kinds of cells in it. Right? The cells that we do have without a tapetum lucidum, we have rod cells and cone cells. And the ones that are less sensitive to red light would be the rods. And then the theory is, okay, so dim red light would not upset your night viewing as much as other kinds of light, right? Well, we're going to see why this is false. We have at the back of our eye, right, the retina is a layer of cells at the back that are sensitive to light, and they come in two different basic kinds, cones and rods. Right? The cone cells can differentiate between red, green, and blue, the primary colors. Those colors are primary to artists and to digital artists, basically because that's how the human eye senses color. We actually have cells that are sensitive in each of those areas. Red are longer wavelengths of light, blue are shorter, and green is right in between, which is where we're most sensitive. And think about it, what's the most predominant plant color on the planet Earth? It's blanketed the Earth in the billions of years, well, the hundreds of millions of years that they've been around. Trees, leafy plants, green. Well, cone cells concentrated in the center of the retina, called the fovea centralis, we like to shorten it to fovea, have three types, blue, red, and green. Rods, high density everywhere else. Most of the retina, especially off angle. When an astronomer tells you to use averted vision, right? That's not perverted vision. I see you in the audience, see you giggling. Averted means to one side, to avert your eyes, put them to one side, look away, right? So when they tell you to use that, they're telling you to use the sensitive rods of your eye. Very good at seeing dim light, but of no color, gray. They tell you look to one side and you'll see dim objects better, like M13 in Hercules, right? A famous globular cluster. Somebody's going to show you that tonight if you ask. Ask to look for Hercules. It'll be up even higher next month when I give my talk, What's Up in the August Sky? First Saturday of the month. We'll look for Hercules. The rods are in high density throughout most of the retina. They number cones 20 to 1. Tens of millions of them, possibly. They have one kind of sensitive chemical, rhodopsin, which peaks in the blue-green area. Keep that in mind. That's going to become important in a minute. Blue-green. Now, rhodopsin lets us differentiate different wavelengths of light to see color. Red light slowly depletes rhodopsins in rods, right? So it's used by those the sensitive cone cells to differentiate that type of color. But there's a problem. There's a really big problem with this myth, and that is that people are not taking into account that rods are not very sensitive to that particular kind of wavelength of light, red. Right? They can see in dim light, right? Generally, no color, but to be sensitive to particular color, 650 nanometers in length. All right, that is something that rods are not good at. And that's the color that people tend to use to try to read star charts. There's a great article, Brian Coberlin, astrophysicist, who says you'll notice that green leaves seem to be brighter in dusk. Why is that? Because the rod cells that are sensitive to dim light are most sensitive in the middle of the spectrum that human beings evolved to see. And that's a very narrow range of the electromagnetic spectrum. Everything from gamma rays down to radio. That's a big range, a difference in wavelengths of light. We're only sensitive to a tiny little range from red to blue. Rods are less sensitive to red. Cone cells are sensitive to the different colors. So you want to use a cyan green light to see in the dimmest possible light that you can still see detail. Right? So what you want to do, if you can find this article by Doug Kniffen, Red Light at Night, Astrolights for Visual Work by Doug Kniffen. This is a tremendous article that explains step by step why you don't want to be using red light to see details. And he goes through this in endless mathematical detail. I'll just briefly summarize that when you turn your light to the dimmest light at which you can still read fine detail, and this is critically important, everybody, fine detail is what you need to see the little tiny black dots on a star chart. Star charts are generally done black on white, easier to see the detail. It turns out that the amount of red that you have to pump up to see that fine detail, because of the insensitivity of your rods, is huge. It's beyond the limit at which you will saturate. And so the best light to read fine detail, it turns out to be in the middle of the spectrum, blue-green. You can't read a star chart when you're fully dark adapted. You can't do it in low light unless you bring up the light that you're most sensitive to just that level where you can just read the star chart. If you wanted to read a star chart by red light, Doug Kniffen points out that you would need the star chart to be as big as a football field, and the smallest stars would have to be as big as dinner plates. Right? Can you imagine how much space you need to spread out your star chart and irritate all the other amateur astronomers at Jenny Jump at UACNJ Observatory? You'd be banging into their tripod. I urge you, please don't do that. Astronomers have spent a lot of time setting up, aligning their telescope to the sky, because the sky is always moving. Why? Why is the sky always moving and shifting? Because the Earth is turning, right? And so astronomers have spent a lot of time aligning their telescopes to the North Star, to the North Pole, actually, which is close to the North Star. So any light that's too bright is going to compromise your night vision, regardless of color. Regardless of color. So the takeaway from this red light myth, what kind of light should you be using to read a star chart by? The answer is dim light. Dim light of any color would be better than a too bright light that compromises your night vision, especially a bright red light. Now, being the perpetual skeptic and pessimist that I am, actually I'm not. I'm actually an optimist. But I'm not optimistic about the idea that people are going to learn anything from what I've just said tonight. Is this going to make any difference in the long run? Will it change anything? Probably not. But I do want you to take away from this that you shouldn't just believe anything that somebody tells you just because they repeat it for 4 decades. Right? Saying the same thing over and over doesn't make it true. Did Shakespeare say a rose, especially a red rose, by any other name would still be a rose? That old saw has been repeated for about 4 centuries, 400 years, maybe more. What did he say? Look it up, everybody. Get on your phones. I'll give you a minute, and I'll give you 10 seconds. Look up a rose by any other name. Now, I'll tell you what the answer is later. What's encouraging to me is now, actually, some people are selling accessories in multicolors. Dim lights, multicolored dim lights. So maybe there's hope after all that I'll see some of you using a dim green light or dim blue light, or the one in between? What's the color in between green and blue? Anybody, artists in the audience? I see a few hands going up. It's a secondary color. Red, green, and blue are primary. Yellow and magenta are two of the secondary colors. Cyan lies right between green and blue. That's the ideal light. All right, so we've nixed a few myths. Human beings did land on the moon. It's an insult to say that they didn't. I saw them do it. When I was a kid, I watched them do it live. There are 6 reasons why people thought there were canals on Mars. It's complicated. The atmospheres of Earth and Mars interfere. Mars has features that are hard to see. The relief is very difficult to see from the Earth. The human vision is tricky. It tends to make us think we see streaks. And Percival, Lowell, and people like him, even nowadays, persuade us by yammering at us repeatedly. The scientific term is yammering, or bloviating. Look up bloviate. Until we believe them. Be skeptical. I urge everybody in the audience, if you've learned nothing from what I say tonight, check things out for yourself. Be skeptical. Don't believe what everybody says just because they say it over and over. Right? Check it. The first planet, Vulcan, may have been a near-Earth asteroid. We're almost certain. There are 8 possible explanations in my book. Oh no, he's mentioning the book again. Seeing. The Earth's atmospheric effects of blurring imagery and ruining things for us. Scientific term, ruining, affects all telescopes equally. Number 5, big telescopes can't see through clouds. They can't see the disks of stars unless they're part of an interferometric array, like the very large array of telescopes out in New Mexico that spread themselves out miles across to simulate a giant disk miles across, in which case they can see fantastic resolution, getting the first image of a black hole in the last couple of years. Did you hear about that? And number 6, my favorite, the best light to see detail, to see detail, to preserve your night vision, not red. I'm sorry to disappoint all you red light enthusiasts. I know you will curse me, you will throw rotten tomatoes at me the next time I'm at Jenny Jump, UACNJ, for What's Up in the August Sky, the first Saturday of August. Don't miss it. But there you have it. I hate to dispel myths. I hate to be the negative, the naysayer, the Debbie Downer. Look up Debbie Downer for those of you who don't know. But there you have it. Oh no! Oh, there's his book again. This book is available everywhere, by the way. Even advertised on my website, astronomyinmotion.com, where you gentle members of the audience, you've been so patient with me. I thank you. I will expect you to go visit because you can play with virtual reality objects without paying for anything. Lots of free samples on the website. Go buy the book if you'd like to play with more samples, more virtual reality models to help you learn about what these mysteries were and how they were solved. Now, before I go, I do look forward to seeing you in person, some of you who will return next time, first Saturday of August. I want to ask you to please pay attention here that we do have a website. It's uacnj.org. Repeat after me, UACNJ. I can't hear you. UACNJ. UACNJ, United Astronomy Clubs of New Jersey. There's a lot of information on our website. You can make a donation to help us. Right, everything is run by volunteers. You know, we do things for love, not money. We are amateur astronomers, not professionals. You can fill out a form to try to get our giveaway telescope. You can check our improvised sales desk and shop. We will eventually be returning back to our original configuration once things have cleared up from the virus situation. When you look through the telescopes, please be careful. Move slowly and cautiously. Let your eyes adapt to the dark. This early this time of the year, in the summer, takes a while before things get dark. I hope that you younger members of the audience will but have your parents allow you to stay a little bit later. We're here till about 10:30, so that you can see a darker sky, because the United Astronomy Club's observing site is among one of the darkest sites in the state of New Jersey, if not the darkest. All right, I hope you enjoy that. And what I'm going to do right now is bring up the lights and see if there are any questions from the audience that could be conveyed. Possibly not. I'm not sure how we're doing this time. It's much easier to do this in person, of course. But I'm going to turn my camera around so you can see me, and wait and see if there's any comments from the audience that I might be able to answer. There are a lot of people there, a lot of experts right among you who can answer questions on astronomy. They are amateur astronomers like myself. I'm no expert. I've been loving and studying the sky for decades. And so among all the amateur astronomers there at Jenny Jump, I fondly call it Jenny Jump, United Astronomy Clubs, you have a lot of expertise. You have people with far more observing experience than I. They've seen sunspots, they've observed through filters, special filters of the sun to watch its features. They've looked at planets, they've seen every planet. I've seen only the 8 major planets. I have not seen the planet Pluto through a telescope or any other means except in books and on websites. Let's see, I can make a comment, but I don't know if I can see comments. No, I haven't. Actually, I am a Facebook newbie, so I actually don't know how to do much. But I do know a little bit about astronomy, just a little bit. So I'm going to thank everybody. I'm going to turn my camera back so that you can see that my little information slide again. I'm going to leave that up. And I'm going to say thank you very much for being patient and seeing my presentation, Red Light and Other Astronomy Myths. And I look forward to seeing you all when I return to UACNJ observatories in August for What's Up in the August Sky. Thanks.